we want to take a quick look at coterminal angles. Two angles are coterminal if they are drawn in standard position and both have their terminal sides in the same location. So we have this little application here that we're going to look at, and we want to look at coterminal angles. And so what we're going to do is, as we drag this around, those two angles are coterminal. So we can keep going around, and as we get here, it's going to snap to it and say they're coterminal. So 75 degrees and 435 degrees are coterminal. And we can keep going. And there's another coterminal angle, 795. And we can do as many rotations as we want. 1,155 is coterminal 75. And we can do rotation after rotation. So if you add in full rotations, you get coterminal angles. What I'm going to do is going to reset this, and we can also realize that if we go in the negative direction, we get coterminal angles. So that one's also coterminal. A negative 285 degree angle is coterminal to a 75 degree angle. And again, we can find many of them. So if we're working in degrees, to find coterminal angles, you can add or subtract multiples of 360, because 360 degrees is one rotation. So we can add or subtract multiples of 360 to get coterminal angles. So as was just mentioned, to find coterminal angles when working with degrees, add or subtract multiples of 360 degrees, because there are 360 degrees in a full rotation. And so what we want to do with 13 through 15, it says find a positive and a negative coterminal angle for each angle. Well, what we can do is we can add or subtract multiples of 360 to get one other positive or one other negative. Number 13, I'm going to just take a couple minutes to talk through a few things. The obvious answer to get a positive is going to go ahead and take the 200 degrees and simply add, negative 200 degrees, and add 360 to it. And that will give us a positive 160 degrees. So there's our positive angle. And then the negative, the straightforward, easiest way to do that is to take the negative 200 degrees, which is already negative, but it wants another one. So we'll subtract a full rotation of 360 degrees, which will give us negative 560. And so there's our answer. Now, a little bit extra here, we could have added or subtracted any multiple of 360. So we could have added 360 times 7, because that's 7 rotations. It's not the most obvious or the easiest to calculate, but we could take 360 times 7, which is 2,520 degrees. That's 7 rotations. We could add that to negative 200, and we would get another coterminal angle of 2,320. So again, not needed, but just showing you could do other things there. So really for this 7, we could put any number in there, and we could find a coterminal angle. And so after doing that, you should be able to find the other ones. And then down here for 16 through 19, find a coterminal angle between 0 and 360. And so a lot of times we'll say this is within the first rotation. And so once again, we can add or subtract multiples of 360. So we could take negative 630. We could take negative 630 and add 360. So you could take negative 3 negative 630 plus 360. Oops, I don't know how that got in there. Negative 630 plus 360, and you have negative 270. Well, that's still not what we want because we want positive, so we can take negative 270 and add 360 again. And that will give us positive 90. So the coterminal angle of negative 630 in the first rotation, or between 0 and 360, is 90 degrees. Now again, we could have simply realized, well, adding 360 isn't going to do it. It's not going to be enough. So we could have thought to start with, let's go ahead and take negative 630 and add two 360s. So add 360 times 2, which most of us know is 720. So you could have done negative 630 plus 720, and you would have found a coterminal angle between 0 and 360. So looking at number 12, that is a large angle, probably many rotations. So a way to think through really large angles, yes, we could take 12,485 and we could subtract 360. In fact, we could subtract multiples of 360. So if we were to think, let's subtract 10 times 360. Well, that would be 12,485 minus 3,600, which gets us down pretty quickly. We could work our way down and maybe subtract another 3,600 and then keep subtracting 360. But another way to do this one, slide over a little bit, is we could figure out how many rotations are there here. So I'm going to slide this all the way over so we can see. Bring out our calculator. So we have 12,485. If we think, well, there's 360 degrees in one rotation, we could divide this by 360 degrees. And so we can take 12,485 divided by 360. Now let's think about this. This means this 34 here, so it says 34.6805555. Looks like it's probably continuing. The 34 represents how many rotations there were, because we divided by 360, which is one rotation. We don't need all those extra rotations, so we are going to subtract all those extra rotations, and we're left with 0.6805 continuing, and this number here represents a part of a rotation. Well, what do we want to do with that part of a rotation? We want to see how many degrees that is. So if we take 0.6805 continuing rotations and then multiply it back by 360, that will give us how many degrees that partial rotation is. So the coterminal angle is 245 degrees. And so what we did, again, is we took our large angle, divided it by 360 degrees, because that's one rotation. We then took off all of the extra rotations, the 34 rotations, and we were left with the decimal of 0.6805 continuing. That was our part of our first rotation. It's part of a rotation, and so we multiply that by 360 degrees to find out how many degrees that is. So that's how you can find coterminal angles when dealing with degrees. So now what we're going to do is look at finding coterminal angles when working with radians. And so over here on the right, I have to find coterminal angles when working with radians, add or subtract multiples of 2 pi, because 2 pi is one full rotation. So 2 pi is one full rotation. Multiples of 2 pi, 2 pi times 1 is 4 pi. 2 pi times 2 pi times 3 is 6 pi. So you're really going to be adding even multiples of pi, or subtracting. So you could subtract 2 pi, or subtract 4 pi, or 6 pi. But a lot of these times, as you notice, these are all fractions. And so just thinking ahead, when we add or subtract fractions, we need a common denominator. So sometimes we're going to have to just take this, maybe 2 pi, and we're going to have to think of this as 18 pi over 9. Or maybe for 21, we'll have to think of it as 8 pi over 4. So it's really easy to find the common denominator. You just, the numerator is double the denominator. I should say the integer in the numerator is double the denominator because we do have that pi there. So we're going to use fractions to help us here. And so this first one says find a positive and a negative coterminal angle for each angle given. Well, this is negative 28 pi over 9. So to find the negative, that should be, we could just subtract because we know that will continue to be negative 28 pi over 9, taking our angle, and we're going to subtract 2 pi. Well, 2 pi, we need a common denominator, so instead of writing 2 pi, we're just going to automatically think, well, that's 18 pi over 9, because we want a common denominator. And 28 minus 18 is going to be negative 46 pi over 9. So that gives us a negative. A positive, we'll go ahead and add 18 pi over 9, or 2 pi. But as you may see or have realized, if we add this 2 pi, that actually doesn't get us out of the positives. We're still at negative 10 pi over 9. So actually we have two answers for negative. So this one isn't positive yet. So we're going to take that negative 10 pi over 9 and add 18 pi over 9, or 2 pi again. And that gives us 8 pi over 9. So here's a positive, and then here's, either one of these is correct, a negative. It doesn't say just there's one answer for the negative. There's actually an infinite number, because we can add several multiples of 2 pi. We could add 50 pi if we wanted to. So we got some positives and negatives. So these were our negative, and this is the positive, or a positive. So that's how you do those. Moving on to the next group, it says find a coterminal angle between 0 and 2 pi for each given angle. Again, this is within our first rotation, just dealing with radians now. So the first rotation. And so you want to add or subtract 2 pi, so our answer is between 0 and 2 pi. So this one, actually it's similar to 20 in that we have this denominator of 9. So we want to add 2 pi, but we know to get a common denominator, we could multiply top and bottom by 9, which would give us this 18 pi over 9. And negative 7 plus 18 is 11 pi over 9. And the way that we know that's between 0 and 2 pi, think of this, is this between 0 and 2? Yeah, it's 1 and 2/9, so this is our correct answer. So as you look at 25 through 27, that's over 12. The denominator is 12. So what do we want to use? Well, we want to use 24 pi over 12 is the form of 2 pi that we want to use. And you can find the coterminal angles between 0 and 2 pi. So in 25, you'll have to subtract. In 26, you'll subtract. 27, you'll add. And actually, 26 and 27, you might need to do a few. You might need to add twice. So that is how you find coterminal angles between 0 and 2 pi.